We will be focused on deciding whether or not we are going to rewrite a function or whether we should undo it. So, in order to close out what we did in the last class, we want to think about some strategies that we already learned in order to solve quadratic equations. We learned that we could solve it graphically. So when you made a graph that looks similar to this here, remember those intersections were the solutions. We also learned how to undo in the last video, because we recognize that if something looks like x squared, if we take the square root, it'll become x. So another example could be if you have x plus 3 all squared, taking the square root of that would give us x plus 3. So by undoing the equation, we are able to make it easier to solve. The next one we are going to learn today, so this is a new one, we're going to learn how to rewrite. Well, to be honest with you, you actually already know how to rewrite, but we will decide whether or not we will undo or rewrite. So rewriting would be if you had something like y plus 2 squared, we would rewrite it and multiply it as y plus 2 times y plus 2. So depending on our quadratic, there may be a best way in order to solve something. So next we are going to try and rewrite one of the examples we already done. So I'm going to go to example 2, the one that had the 2 i's. And here, notice we already solved it graphically and we undid it. However, I want to show you how to undo with something we've already done and then decide which of these answers, or which of these strategies rather, would have been the best way. So if I rewrite this one, so this is step 3, rewrite. I'm going to rewrite the equation. So something that's very important to know is that if something's being squared, that means that you multiply it 2 times. So I'm going to take x plus 3 squared and multiply it. And also, I didn't do anything yet, so I'm going to just set everything else to be the same. So I want to do my work on the side. So that x plus 3, I'm going to create a box and multiply it to where I have x squared. 3 times x is 3x. X times 3 is 3x. 3 times 3 is 9. So that means that I can add these two together to give me 6. So I have x squared plus 6x plus 9. I'm going to write everything else out. Minus 5 equals 3. Because I have some like terms, I am going to reduce. So for instance, here I have a like term, so I'm going to reduce that. So x squared plus 6x plus 4 is equal to 3. I'm going to just copy that in blue for us, because remember, 9 minus 5 is 4. And in order for us to maybe factor it, this 3 has to go over here in order for it to equal 0. So next I'm going to subtract 3 from both sides. The process is the hope that we'll be able to factor this. So I have x squared plus 6x, plus 1 is equal to 0. And so now the hope is that we should be able to factor this, okay? So remember, we want it like this, okay? This is a yes. We want it like this. So now what we're going to do is we're going to take this to factor. I'm going to make an x on the side. So I want to know what times what gives me 1, but added gives me 6. What times what gives me 1, but added gives me 6? To be honest with you, we can't do this in our mind. We don't know. So you would either have a few options. You could do the quadratic formula, but we don't want to do the quadratic formula. But maybe this wasn't the right way. So I wouldn't rewrite this one. In fact, I would have undid it. So by undoing it, we were able to see that we do have a square root, and this actually gave me the most accurate answer. So that's how we figure it out. However, let's see if it would have been the best idea to rewrite or to undo some of the examples that we've already done. So I'm going to go back. I'm going to go back one, and here is one of our examples where we actually already graphically found it and we undid it. Notice how when you undid this one here, they gave us integers. They gave us numbers without decimals. This one, you could have definitely rewrote, and you would have received the same answer. So if you like to factor, this would have been a great one to rewrite. However, if you look at the structure of it, maybe undoing it was a bit easier. Let's go and find a different example. All right, now this example here was the one that had the I, or the imaginary solution. Notice how because we already checked on a graph that it was imaginary, I wouldn't have rewrote it, because if I rewrite and I factor it, it'll be very hard to figure out what these answers were when I factor. So this one I would not rewrite. Integer solutions. And remember, integer just means that there's no decimals. And they're real. So they're real without decimals. All right, so notice even this structure here. Because I see that I have something that looks like x squared, except x is expanded in this example, I should undo something like this. Now, we're going to do two examples where rewriting is the best idea. So we are going to rewrite, let's rewrite H, and then we'll rewrite C. So we'll go backwards. So H, on the other hand, if I try to undo it, so let me use a pencil because this is actually incorrect. So if I try to undo, I would have to take every term. Remember we learned about terms. I would have to take every term and take the square root. That just made our problem more complicated. So undoing is not the right decision. I could do this graphically, and I could also rewrite it. So Miss M is going to go grab a calculator, and we are going to we're going to graphically do it, and then we will rewrite it. Now, if you are not in class, what you can do instead is use Desmos, and I'll make sure to put Desmos in the link for you all in order for you to access it. So here we have two equations again. Although it's a bit complicated, we still have two examples, or two equations rather. So my first equation I'm going to put into my calculator is 4 times x plus 2 minus 5. The next one I'm going to put in my calculator is y equals 0. This is going to create that intersection that will tell me what my solutions are. So I'm going to go to y equals x plus 2 squared plus 4x plus 2 minus 5. And my next equation will be 0. I'm going to press graph. And I'm going to trace what I see. Or rather, just copy it down. So y equals 0 is in fact the x-intercept, or the x-axis rather. So if I do this here, I'm going to use colors to help me. My line is not straight, but you get the point. Here is my y equals 0. And I notice that they seem to intersect at very clear points on the x-axis, and they're both on the left side. Just make that clear. So you have this intersection and this intersection. So those two intersections are our answer. So if I wanted to trace it, if I trace it, I can see that the answer is in the middle here. And if I go to the other side, my answer is in the middle here. But if I can rewrite it, maybe I'll find a different way to actually find the precise answer. So we know we can't undo. We did it graphically. Now let's try to rewrite it. I'm going to rewrite the question. So there's actually a lot going on here. The first part is we have to do x times x plus 2 times x plus 2. Next, we have to distribute right here. So I'm going to do that now. I have 4x plus 8. And I'm going to write everything else out. So I have minus 5 equals 0. So notice that I went to each term to see what did I need to do in order to make that. Sorry, that was a little blurry. Hope that's a bit more clear. So on the side, I'm going to multiply x plus 2 times. So I have x squared plus 2x plus 2x plus 4. Remember, we need to combine these terms here. So I have x squared plus 4x plus 4. And I'm going to write everything else out since I already did that part. Now we need to combine like terms. So I'm going to take a few colors and I'm going to highlight the terms that are alike, meaning they have the same variables. So I see x squared has nothing. 4x can be added with 4x. And then 4 plus 8 minus 5 can be added together. That means I'm left with x squared plus 8x plus 7. 4 plus 8 is 12, minus 5 is 7. So hopefully we can factor something like this. So I'm going to take this here and I'm going to factor it to the side. What times what gives me 7, but added gives me 8? Huh. Well, 1 and 7 do. So therefore I have x plus 1, x plus 7. Now, we didn't go over this together, but you did this in IM2 last year. Because we have something that's equal to 0 and they're being multiplied, that means I have two equations. I have x plus 1 is equal to 0. I also have x plus 7 is equal to 0. So I'm going to subtract from both sides. So my first answer is x is equal to -1, which is what we saw in our calculator. And we also are going to do the same thing with the plus 7. So now your x value is equal to -7. And so that's how we rewrote it. We have one more example of rewriting. And let's see if we can use more than one strategy together in order to get to where we want. We're going to go back to C. All right, so C, if you look here, we don't have any x squares. So even thinking about undoing isn't necessarily the best idea. There is a way you could undo, but I will leave that for us to worry about another day. So let's try to rewrite this one. I am going to multiply first these two in order to get an equivalent equation or expression that could help us out. I'm going to rewrite it over here. We have 2y minus 3. We also have y minus 2. So I have 2y squared, negative 4y, negative 3y, and a positive 6. So I'm going to write this all out. So I square. These two here is going to give me a negative 7y plus 6 is equal to negative 12y plus 18. I'm going to do my best to move all the terms to one side. So let's start off with the y, the 12y. I'm very comfortable with moving terms to the other side, and that's what we're learning now. And I can only combine terms that are alike. So you can only combine the ones that have the same variable. So I have 2y squared plus 5y plus 6 is equal to 18. Next, I'm going to move my 18 over. Now I have 2y squared plus 5y minus 12. And so something like this is actually, you can't factor it in your head. Not because of the 2. We'll learn about how to factor when you have a number coefficient here, but actually you're going to get a decimal answer. So what we are going to do is I'm going to show you how you can put this into your calculator graphically. So in y equals, we're going to change all of our y's to x's. That's just going to make sure that our calculator understands what we want to find. So I have 2x squared. Remember to use Desmos if you are at home. Minus 12. And I'm going to graph my new function. I still left y is equal to 0 just because. I know I can't see the vertex, but for this equation, that's okay. If you really do want to see the vertex, you can do zoom and then press the number 6. That means you're going to change it to standard. Oh, sorry. I just did the same thing. In order to fit it, I'm so sorry, you have to do a window and then fit. So give me one moment. You're going to go into zoom. Oh, I'm just messing up, y'all. I'm so sorry. So we're going to go into zoom, and we're going to go to zoom fit. So 0. When you say zoom fit, you're asking for it to fit the equation for you so you can see it completely. So notice that it's the same shape, but it just looks a little different because I'm fitting it. However, the whole reason why we're doing this is that we're trying to find the intersection. So I can see it here and I can see it here, but we're going to have them calculate it for us. We're going to calculate it by pressing second trace. Second trace means that we're pressing the calculate button. And I'm going to scroll down to where it says intersect. They're going to ask for the first curve. They're going to ask for the second curve. So first line, second line. The last question is going to ask you to guess. So that's my first guess. So they tell me that the intersection is when my x value is equal to -4 and my y is equal to 0. So I know that my first one is when my answer is -4, 0. Remember, our x value is the answer. However, tricky part, because they used y in the equation, we need to say that y is equal to -4 because we don't have any x's. Let's do that one more time. I'm going to press second, calc, go down to intersect, show them my first curve is the one in blue, my second curve is the one in red, Now you want to go over and give them a good guess. Because we have two answers, you want to be precise of which one you want them to give you. My next one is at positive 1.5, comma 0. Is when your y value is equal to positive 1.5. So that is the trick that's been sitting in there the entire time. You can always use a calculator in order to help you. If you were using Desmos, if you click on it, it would actually show you where your intersection is. So make sure you hover around and click on your intersection if you're on Desmos. Thank you all. This is what we did today. Make sure that you complete the exit ticket if you're at home, and I hope you have a great day. Bye.